Alright, example number 4. 3 wooden blocks connected by a rope of negligible mass are being dragged by a horizontal force. So it has give us the information that we need. Show me. And then we have these 3 blocks of system here where we have to find the acceleration as well as the tension of rope T1 and T2 here. Okay, so now let's firstly draw the free body diagram for each of this block. So this is M1, M2 and M3. So now we have to draw the arrows of forces. So M1 we know would have the weight, and then it will have the force there as well as the normal force, and then we have the T1 experienced by the M1. Then let's look at M2. It has weight, gravity pull, and then pulled by T1 and T2 as well. And then it has the normal force. And then let's look at M3. Same thing, weight, and then tension, and then normal force. Okay, so that is that. Now let's write it down. M1G, T1, N1, F. M2G, T2, N2, T1. And then M3G, T2, N3. Okay, so that's the free body diagram. And then, since now we are looking for the acceleration of the block, we have to follow, if the forces are following the direction of the acceleration, it will be considered positive. Okay, if the forces is against the acceleration, the direction of acceleration, meaning it will be negative. Okay, untuk ini ja, untuk yang ada acceleration, you have to consider itu saja. So we don't follow yang convention positive, negative. Kalau dia ada acceleration, kalau dia follow direction of acceleration macam ni, dia positive. Okay, now let's continue. So now I won't do it on a table, I would just write it down. So total force at X is equal to MA. Okay, so let's look at block number 1. We have F following the direction of acceleration, so positive minus T1 because it is against the acceleration. M1G, M1 is 3G. 3G, silap. M1G is basically just write 3A lah. Kenapa saya blur? M1 is just letak M1G lah dulu, nanti baru substitute. So this is equation 1. And then we have for second block, T1 positive minus T2 equal to M2A. Bro, wrong. This one is A. Sebab itulah ni tiap tulis terus. So this one is M1A. Okay, Fx equal to M2A. Macam tu. And then for the third block, total Fx is equal to M3A. So M3 T2 equal to M3A. Okay? Alright, now we are looking at the X component. Sorry, just now I write G sebab I thought we were looking at the Y component, which is wrong. We are looking at the X component. Right? Now, this is equation 1, equation 2, equation 3. So from 3, we can substitute 3 into 2. So T1 minus M3A equal to M2A. And then from 1 can let T1 equal to M1, F equal to T equal to F minus M1A. So this is equation 4. So we can substitute 4 into, no, this is let me renumber that. This is equation 4, this is equation 5. So substitute equation 5 into equation 4. So F minus M1A minus M3A equal to M2A. Okay, now we are looking for the acceleration. Acceleration. So, and then force is given. So M1, M2, M3 is also given. Then we can find the acceleration to be equal to 20.8 meter per second square. Okay, so that is the final answer for the acceleration of the system. And then now question B, we have to find the tension 1 and tension 2. So that is just substituting the values. Substitute A into equation 5 and equation number 3 to find T1 and T2. So T1 is just 1000 minus M1, which is 3, acceleration is 20.8. Then you'll get T1 to be 936 Newton. And then tension 2 is just M3A. So equal to M3 is 30 kilogram, A is 20.8. You'll then get 624 Newton as the final answer for the tension. Okay, so that is our example number 4.